Good morning, everyone. My name is Audia Florencia, and I am joined by my colleague Christine Kosasi. We are both from the Computer Science Department at Bina Nusantara University. Today, we are here to present our research titled Predicting Netflix Show Success, a Sentiment Analysis Approach Using BERT.
The global entertainment industry, especially streaming platforms like Netflix, has seen massive growth in recent years. With thousands of titles available, understanding what makes a show successful is crucial for both content creators and streaming services. Traditionally, viewership numbers or ratings have been used, but this often fails to capture the nuance of audience sentiment. That's where our approach comes in. By analyzing textual reviews, we aim to tap into audience opinions more deeply and meaningfully. However, sentiment analysis methods have historically struggled to detect contextual subtleties, including sarcasm and linguistic ambiguity. To address this, we leverage BERT, a transformer-based model which captures richer conceptual information and significantly improves sentiment classification accuracy.
Our research is guided by several key objectives. Firstly, we aim to develop a predictive model for Netflix show success based on the sentiment extracted from user reviews. Secondly, we seek to analyze the correlation between observed sentiment trends and viewership success metrics. A core component of our methodology improves utilizing BERT for the binary classification of user reviews into positive or negative sentiment categories. Ultimately, the insights from this research are intended to assist streaming platforms in making more informed data-driven content decisions.
We will now outline the methodological framework of our study. First of all is data collection. We began by collecting Netflix review data from the trained CSV and tested CSV files. The original dataset contained over 374,000 samples, which we filtered down to around 77,000 that were specifically relevant for sentiment analysis. For the second is preprocessing. This crucial step involves several text cleaning processes, such as removing emojis, converting text to lowercase, eliminating special characters and extra white space, and applying tokenization, stemming, and lemmatization. For the third is data splitting. In data splitting, we divided the data into training, validation, and testing sets, using a 70% split for training, 10% for validation, and 20% for testing. To maintain balanced class distribution, we applied stratified sampling across all subsets. For the fourth is tokenization. To make the data compatible with Word, we converted the text into numerical tokens using the BERT-based uncased tokenizer. For the fifth is model architecture. Our model is built on the preterm BERT-based uncased architecture, using the auto model for sequence classification from the Hugging Space Transformer library. We added a softmax classification layer to enable binary sentiment predictions. For the next is training. The model was trained for 5 epochs using the Adam optimizer, which is well suited for transformer models. We use cross-entropy loss as the loss function. And for the last is evaluation. After training, we evaluated the model's performance using standard metrics, accuracy, precision, recall, and F1 score. We also generated a confusion matrix to better understand how well the model distinguishes between positive and negative sentiments.
This slide illustrates the overarching system architecture of our research. The process commences with the raw reviews, which then undergo pre-processing to clean and standardize the textual data. Subsequently, the data is subjected to tokenization using the BERT framework. The processed data is then fed into the model training and prediction module. This leads to the sentiment classification of the reviews, which ultimately facilitates the analysis of show success.
We present here the empirical results of our model's performance. The confusion metric on this slide visually summarizes the classification outcomes. For the positive class, represented as label 1, the model demonstrates high accuracy, correctly classifying 8,123 out of 8,535 instances. For the negative class, labeled 0, the accuracy was slightly lower but still strong, with 6,520 out of 6,989 instances correctly identified. The F1 score, which is the harmonic mean of precision and recall, was 0.95 for the positive class and 0.94 for the negative class. The weighted average F1 score for overall performance was 0.946. Furthermore, we tracked the training and evaluation accuracy across 5 epochs. Training accuracy consistently improved, reaching 99.13% by the final epoch. Evaluation accuracy remained high, peaking at 94.34%. This metric highlights the model's effective learning and strong ability to generalize on unseen data.
Reflecting on our results, several key observations warrant discussion. The model exhibited strong performance, particularly in the accurate prediction of positive sentiment. A slight indication of overfitting was noted beyond the third epoch, where the evaluation loss began to increase despite continued reduction in training loss. This suggests that while the model performed exceptionally on the training data, its generalization to novel data experienced a minor decline. Crucially, our findings indicate a visible alignment between sentiment trends derived from the user reviews and the observed popularity of Netflix shows. BERT's inherent ability to capture complex semantic relationships within the textual data proved instrumental in achieving these results. However, our research also highlighted several ongoing challenges in sentiment analysis, including the nuanced detection of sarcasm, the need for domain adaptation, issues related to class imbalance within datasets, and the complexity of multilingual content.
In conclusion, our study clearly shows that purpose sentiment analysis is an effective method for predicting the success of Netflix shows. This advanced approach significantly outperforms traditional sentiment analysis models in both precision and recall metrics. The practical implications of these findings are substantial. Streaming services can strategically leverage sentiment data to improve their marketing efforts and guide their content acquisition and production strategies. By doing so, they can adjust audience engagement and boost the overall performance of their shows.
To formally document our research, we submitted our paper to 2025 Fifth International Conference on Electronic and Electrical Engineering in Intelligent System (ICE3IS) through the EDA submission system. As you can see, me and my colleague are the authors affiliated with Venus University. We sincerely thank you for your attention and time during our presentation.